Let us see the next one. And before starting the next one, I would like to conclude one more small thing, that is the properties of our conjugate symmetric signal and anti-conjugate symmetry. Basically, the natural tendency of the signal has some natural properties. Properties in the sense, usually for example, if I have a conjugate symmetry, right? If I have a conjugate symmetric signal, right? For a conjugate symmetric signal, it has two parts. Conjugate symmetric signal has two parts. One is real part, right? And another one is imaginary part of the signal. It might be continuous time domain or discrete time domain, right? But it has two parts. Conjugate symmetric signals are having two parts. One is real part, another one is imaginary part. The natural tendency is real part of the conjugate symmetric is always even. Real part of the conjugate symmetric signal is always even, whereas imaginary part of the conjugate symmetric signal is always an odd function. Clear? Similarly, when I am discussing about anti-conjugate symmetry, right? So if I am looking for anti-conjugate symmetry with respect to, that is in continuous time domain or discrete time domain. See, okay, let me come to this one. So there is a real part of the anti-conjugate symmetry plus imaginary part of the anti-conjugate symmetry. In case of anti-conjugate symmetry, real part of the anti-conjugate symmetry is always an odd function, right? Whereas imaginary part of the anti-conjugate symmetry is always an even function. Clear? Don't forget, because this is very important property. This property is very important. Okay, I hope now you are getting clear idea. Just remember it. This is the relation, and you can also keep the same relation will be valid for discrete domain also. In discrete domain, there is conjugate symmetric discrete domain. We know how to write. It should be equal to real part of the discrete domain signal is always an even function, whereas imaginary part, right? Imaginary part of the discrete domain signal is always odd function. Conjugate symmetric. Similarly, if I am doing the same thing for anti-conjugate symmetric, right? In anti-conjugate symmetric, real part of the anti-conjugate symmetric is always an odd function, whereas imaginary part of the anti-conjugate symmetric, right? Wait a minute. Imaginary part of the anti-conjugate symmetric. This is imaginary, right? This is x, right? So x I imaginary. This imaginary part of the anti-conjugate symmetric is always an even function. Clear? So that is the difference between conjugate symmetric and anti-conjugate symmetric, right? So let us talk about the next beautiful signal, that is called periodic signals and aperiodic signals. Keep that in. Next we are going to discuss about periodic and aperiodic signals. Let us understand the beauty of periodic signal. What do we mean by periodic signal, and where we are going to use this periodic signal, right? So first thing is periodic, right? That name indicates periodic in the sense. Well, I will explain it with the example in order to get the better idea, right? Periodic signal in the sense, for example, let us assume I have a signal like this, right? A periodic signal. I have a signal. That property is like this. It is keep on going like this, right? Similarly, in the imaginary domain also, that signal is keep on going like this, keep on going like this, right? Not the imaginary domain, that is in the left side and the right side. This is y-axis and this is x-axis. With respect to time period, I have a signal. That signal is traveling like this. Now, I am just observing this signal. What we are trying to analyze in the observation, actually given it is a sinusoidal signal, yes or no? Yes. Given it is a sinusoidal signal. And the property of this sinusoidal signal, if I am going from minus infinity to plus infinity, or signal you observe, see there, first I am considering a proper signal. First 360 degree on the signal select 0 to 360 degree, or I can say from 0 to 2 pi. The interval is I am just considering from 0 to 2 pi. In between 0 to 2 pi, I am observing its property like this. And then I would like to consider this. Again, I am analyzing this property in between 2 pi to 4 pi. Right? 2 pi to 4 pi. Just observe from 2 pi to 4 pi. Is there any changes? No. From 0 to 2 pi, what signal from 2 pi to 4 pi also, we are getting same property. Again, from 4 pi to 6 pi, we are getting same property. From 6 pi to 8 pi, we are getting same property. Again, from 0 to minus 2 pi, we are getting same property. From minus 2 pi to minus 4 pi, we are getting same property. So the thing is, if a signal is repeating itself after regular interval of time period from minus infinity to plus infinity, then the signal is called periodic signal. If a signal is repeating its property, if a signal is repeating its same property, it's repeating its property after a regular interval of time period with the period of 2 pi, the sinusoidal signal is again and again repeating its nature from minus infinity to plus infinity. அப்ப 0 ல இருந்து 2π வரைக்கும் நான் இந்த சிக்னலோட ப்ராப்பர்ட்டி எப்படி அப்சர்வ் பண்றனோ சேம் ப்ராப்பர்ட்டி I am observing from minus infinity to plus infinity. So if a signal is repeating itself, right, the tendency of the signal, if it is repeating itself, its own property is again and again being repeated with a proper time set interval, then that signal is called periodic signal. Now instead of going with the 2π and 4π and all, let me generally define t, 2t, 3t and so on. Similarly left side minus t, minus 2t, minus 3t and so on. If the signal வந்து நீங்க carefully observe பண்ணி பாருங்க, what we are trying to understand from here, if I carefully observe the signal can be written as, for example, let me write first signal, let me call it as x of t. First signal alone I am calling it as x of t. Second signal, let me call it as x of t minus t. Why? See there, x of t இதோட முடிஞ்சது 0 ல இருந்து t ஓட முடிஞ்சது, that is the period of the x of t, right? So period of the x of t is t. When I am observing the second signal, it is starting at t. Second signal x of t minus t அப்படினா same signal, same property எங்க இருந்து ஸ்டார்ட் ஆகுது பாருங்க. Instead of starting at r, now it is starting at t equal to t. T minus t in the sense t equal to t. That signal is going to start at t, again it is going to repeat. See there, the property of x of t and the property of x of t minus t are going to be equal. ஒரே மாதிரி தான் இருக்கு. See there, t minus t அப்படினா t equal to t ல இருந்து 2t வரைக்கும் நம்ம அப்சர்வ் பண்ற ப்ராப்பர்ட்டியும் x of t அப்படினா 0 ல இருந்து t வரைக்கும் நீங்க அப்சர்வ் பண்ற ப்ராப்பர்ட்டி ஒரே மாதிரி தான் இருக்கு. So the conclusion is x of t and x of t minus t are identical to each other. Same way நீங்க left side அப்சர்வ் பண்ணி பாருங்க. If I am going in this direction, right? If I am going in this is x of t. Let me consider this is x of t. Then here this will be x of, we can write as x of t plus t. T plus t in the sense t is equal to minus t, I have a signal. Clear? That signal is repeating its what is this? Let me take like this. That signal is repeating itself from minus t to plus t. So the conclusion is, whichever the property that I am observing in the first cycle, same cycle will be repeated, same cycle will be repeated. So the thing is, x of t minus t, x of t plus t, x of t minus 2t, x of t plus 2t, all are going to be equal. So let me write like this, x of t should be equal to x of t minus t, right, should be equal to x of t minus 2t. You can also start at 2t, same property you can observe, again and so on, it will be continuous up to x of t minus n times of t. Whereas in the left hand side you have to repeat, right, same thing you can repeat up to x of t plus times of nt. T plus nt equal to t equal to minus nt. So that is the nature of the periodic signal. A signal is repeating its property from minus infinity to plus infinity, from minus infinity to plus infinity. A signal is again and again repeating its property with a proper time interval, with a set of time interval, that is called periodic signal, right? So அப்ப ஜெனரலா நம்ம என்ன பண்ணுவோம், the conditions, general condition என்ன அப்படினா, first you have to, நீங்க இது எல்லாத்தையும் செக் பண்ணி பார்க்க வேண்டிய தேவை கிடையாது. ஃபர்ஸ்ட் இந்த ரெண்டு ப்ராப்பர்ட்டி மட்டும் செக் பண்ணா போதும். if x of t is equal to x of t plus t or minus t, either you can test in the left side or right side, ஏதாச்சும் ஒரு இடத்துல if x of t is equal to x of t minus t or x of t plus t equal ஆ வந்தாலே that signal is called periodic signal. Clear? That signal is called periodic signal. That is the natural property of the periodic signal, right? Now see, next listen, you have to understand this property clearly. Periodic signal in the sense it has to repeat its property from minus infinity to plus infinity. That is very important. For an example, if the same sinusoidal signal is only going from 0 to infinity, see that it is going like this, like this, like this, it is going exactly, that is correct. But in the left hand side, from minus infinity to 0, my signal is 0. From 0 to infinity, it is what? It is see that after 2 pi again it is repeating. After 4 pi again it is repeating. Of course that is correct. But in the left hand side, it is not repeating itself. No? From minus infinity to 0, it is not repeating itself. From 0 to infinity only, it is repeating itself in the sense that is not a periodic signal. That is called aperiodic signal. Such a type of signal is called aperiodic signal. Periodic signal in the sense from minus infinity to plus infinity. Interval is, the time period is what? From minus infinity to plus infinity, it has to repeat itself, right? In the condition எங்க இருந்து எது வரைக்கும் satisfy ஆகணும் அப்படினா from minus infinity to plus infinity satisfy ஆகணும். In order to design, that is in order to bring, that is in order to call the signal as a periodic signal, right? In the condition infinity வரைக்கும் எல்லா இடத்துலயும் satisfy ஆனா என்ன ஆகும்? That signal is called periodic signal, right? So that is the difference, right? Now you might get the very clear idea, right? So இந்த மாதிரி condition வராது எல்லா சிக்னலும் என்ன சிக்னல்? All the signals are, rest of all signals are called aperiodic signals, right? So finite derivation signals are always aperiodic signals. finite derivative signal. For example, let me take one more example. See, I have a signal like this. Exist. Now see there, is it periodic or aperiodic? Aperiodic signal. Why? Periodic signal in the sense, from minus infinity to plus infinity. For example, if the signal is coming like this, it is keep on coming like this. What I can say is keep on coming like this. It is repeating itself. From minus infinity to plus infinity, ஒரு particular interval வச்சிட்டு அதோட property திரும்ப minus infinity to plus infinity repeat ஆச்சு அப்படினா, then that is called periodic signal. But here see that I have only one cycle. After that I have 0. Here it is 0. Right? Is it periodic? Is it repeating itself? No. So that is called aperiodic signal. Such type of signals are called aperiodic signal. So that is the difference between periodic and aperiodic signal, right? So till now I have been, that is given explanation for only one signal, right? அப்ப ஒரே ஒரு சைன்ஸ் அந்த சிக்னல் மட்டும் minus infinity ல இருந்து plus infinity க்கு டிராவல் பண்ணிருந்தா ஓகே. That is அது நம்ம என்ன பண்ணிக்கலாம், டைரக்டா பீரியட், that is periodic and aperiodic signal அப்படி நம்ம டிஃபைன் பண்ணிடலாம், right? So the conclusion is a signal is said to be periodic, right? A signal is said to be periodic if and only if satisfies the condition of x of t is equal to x of t plus or minus t, right? So that is the condition for a periodic signal. Otherwise your signal is said to be aperiodic, right? Now whereas periodic signal அப்படினா meaning என்ன, time period of the signal will be set interval. இப்போ நம்ம sinusoidal signal எடுத்தோம் அப்படினா 0 to 2 pi is the time period. ஏன் அதுக்கு அப்புறம் அதே சிக்னல் தான் திரும்ப ரிப்பீட் ஆகுது அப்படிங்கறதால you don't need to consider the all time period, you can consider only first cycle and its corresponding time period, right? So always for a periodic signal, time period is fundamental time period. That is t is called, for a periodic signal t is called fundamental time period. The time period will be always free definite. That is called fundamental time period. For a periodic signal, this fundamental time period is always predefined. இத வந்து நம்ம டிஃபைன் பண்றோம். Whereas for aperiodic signal அதோட ப்ராப்பர்ட்டி நமக்கு தெரியாது. அது ஒரு டியூரேஷன்ல எக்ஸிஸ்ட் ஆயிருக்கும், இன்னொரு டியூரேஷன்ல எக்ஸிஸ்ட் ஆயிருக்காது. அப்ப அந்த சிக்னலுக்கு வந்து ப்ராப்பரா இதுதான் இந்த சிக்னலோட டைம் பீரியட்ன்றது நம்ம ஃபண்டமெண்டலா செட் பண்ண முடியாது. அதே மாதிரி திரும்ப அது ரிப்பீட் ஆகும், அந்த மாதிரி நம்ம சொல்ல முடியாது, ரைட்? So when you are considering periodic signal time period is called fundamental time period. I am just considering the first cycle, right? And same cycle is going to be repeated, so you don't need to consider all these cycles, just consider the fundamental or first cycle. Now and then how we are going to find out this fundamental time period? For that we have the formula, right? So the fundamental time period can be calculated with the help of 2 pi by omega. Simply we can say, right? So that is the formula to obtain. That is, you don't need to memorize these things, right? Omega can be written as 2 pi f. We all know frequency, right? So frequency of a cycle can be written as 2 pi by t, 1 by t. We all know frequency and time period are going to be reciprocal to each other. So that is the frequency of the fundamental cycle, whereas it is the fundamental time period, right? So from this, if you want to know the fundamental time period of the signal, it can be written as 2 pi by omega. So you don't need to memorize this one. That is very simple formula. Clear? So that is how we are finding the fundamental time period of the periodic signal. Suppose if your signals are given, if you are having more than one signal, the linear combination of more than one signal with a different frequency, right? So let us take, for example, if I have a signal, that is if I have more than one signal with the linear combinations, right? Let us take, I have two signals, right? I have two signals with the linear combination of two different frequency signals, right? For example, first case I have a signal a into x1 of t, right? And then second I have a signal b into x2 of t. First I will take two signals and then we will define the first step. இப்போ ரெண்டு சிக்னல் வந்துச்சு அப்படினா how to check? ஒரே ஒரு சிக்னல் மட்டும் இருந்ததுனா சிக்னலை பார்த்த உடனே நீங்க கெஸ் பண்ணிடலாம், right? You can find out we can define whether that signal is periodic or aperiodic. அதை நீங்க பார்த்த உடனே சொல்லிடுங்க, nature of the signal will give us, right? But the thing is, அப்ப ஒரே ஒரு சிக்னல் வந்தா I will tell you while taking the examples you'll get the very clear idea, right? So சிக்னலை பார்த்த உடனே சொல்லிடலாம் சார், ஒரு சில சிக்னல்ஸ்லாம் வந்து காம்ப்ளிகேட்டடா இருக்கும், அது பீரியடிக்கா இல்லையா அப்படிங்கறது உங்களால டிஃபைன் பண்ண முடியாத மாதிரி இருந்தா you can go with the conditions. Condition அப்படினா என்ன கண்டிஷனா, you have to test the signal with the help of we know now x of t is equal to x of t plus t or t minus t. You can just say one property. With the help of this condition you can find out, right? First x of t will be given, find out the value of x of t plus t, and then if they are going to be equal, then the signal is called what? Periodic signal. Otherwise the given signal is aperiodic signal, right? So in that way we can easily define, you can easily find out the periodicity and aperiodicity of the signal, right? Okay, first I will take one example for this, then we will define this one, because later instead of going with different approach I will just stop this one. I will explain this one here itself, right? First I will complete this one, then we will take this one, right? So here for example, if I take a signal, right, for we will take sin t itself, given it is sin t, x of t is given as sin t. Now the question is, you are requested to test the periodicity of the signal. How will you find out the periodicity, right? X of t is given. Now we have to find out the value of x of t is given. We have to find the value of x of t plus t. X of t plus t. அப்ப என்ன பண்ணுவீங்க? It can be written as sin of t plus t. Sin of t plus t. அப்ப இத ஃபைண்ட் பண்ணீங்கன்னா see there, now we have to do, எனக்கு என்ன தேவை அப்படினா இந்த சிக்னல் பீரியாடிக் சிக்னலா இருக்கணும் அப்படினா x of t யும் x of t plus t யும் ஈக்குவலா இருக்கணும். அப்படினா மீனிங் என்ன? இந்த sin of t plus t ஓட வேல்யூ once again எதுக்கு ஈக்குவலா வரணும் அப்படினா it has to be equal to the value of sin t. திரும்ப அது sin t க்கு ஈக்குவலா வரணும், ரைட்? சோ அந்த கேஸ் எனக்கு வரணும் அப்படினா what I have to do? அப்ப அந்த sin t வந்து திரும்ப வந்து என்ன அதோட சைக்கிள் வந்து எப்ப ரிப்பீட் ஆகும் அப்படினா if the value of t will become equal to the value of 2 pi, that is the point where the signal is going to be repeated once again, where this signal is going to be repeat itself. Are you getting me? So the conclusion is here, if the value of t, right, so the time period, if the value of t is going to be 2 pi, if it is equal to 2 pi, then what will happen? Sin of t plus 2 pi, right, sin of t plus 2 pi should be equal to what? Sin t. Sin of t plus 2 pi should be equal to what? Sin t, right? So in order to apply, அப்ப இந்த கண்டிஷன் இதுக்கு ஈக்குவலா வரணும் அப்படினா இந்த மாதிரி கண்டிஷன் வரணும் அப்படினா t is equal to what? We have to define it as 2 pi, right? So that is the way how we are finding the value of, what I can suggest, how we are finding the value of periodicity of the signal, that is period of the signal, right? Period of the signal. But the thing is, when we have more than one number of signals, so இது வந்து நீங்க ஈஸியா ஃபைண்ட் பண்ணிடலாம். சார் ஒரே ஒரு சிக்னல் கொடுத்திருக்காங்க, sin t வந்து பீரியாடிக் அப்படிங்கறத நம்ம அப்படியே டிஃபைன் பண்ணிடலாம். பட் திங்க் இஸ் வாட், நீங்க செக் பண்ணி பார்க்கணும். இப்போ sin of t plus t போட்டு அப்படினா இது வந்து இந்த சிக்னல் வந்து பீரியாடிக்கா இருக்கா இல்ல ஏபீரியாடிக்கா இருக்கா அப்படிங்கறத நீங்க செக் பண்ணி பார்க்கணும், ரைட்? So sin of t is periodic in the sense it has to repeat. Sin t எப்போ ரிப்பீட் ஆகும்? After 2 pi it will be repeat itself. That things we know. So further than considering, அப்ப t equal to we are testing, t equal to pi னு போட்டா இது ரிப்பீட் ஆகுதான்னு செக் பண்ணி பார்க்கணும். அப்ப t equal to 2 pi னு போட்டு பாத்தீங்கன்னா ரிப்பீட் ஆகுதான்னு செக் பண்ணி பார்க்கணும். t equal to 2 pi போட்டா அப்படினா minimum time period. At t equal to 2 pi the signal is repeating itself. Yes. So x of t and x of t plus t will be equal at t equal to 2 pi. So given signal is periodic. நீங்க செக் பண்ணி பாருங்க. Trial and error procedure only, right? So again you can substitute 3 pi போட்டு பாருங்க. 4 pi substitute பண்ணி பாருங்க. Again sin of t plus 4 pi equal to sin t only. So the conclusion is, with the time period of t is equal to 2 pi, the signal is keep on continuing, repeating itself. So that is called the period. That is what I can say. This is called fundamental period of the given signal. And the given signal is what? Periodic in nature. This given signal is periodic in nature. Suppose நீங்க t க்கு எந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணாலும் என்ன ஆகும் அப்படினா இந்த மாதிரி கண்டிஷனே வரல. சார் நான் t க்கு வந்து pi சப்ஸ்டிட்யூட் பண்றேன், 2 pi 3 pi 4 pi 6 pi எந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணி பார்த்தாலும் I am not getting, sir, I am not getting periodicity. எனக்கு வரவே இல்லை அப்படினா அந்த மாதிரி ஒரு கண்டிஷன் வந்துருச்சு அப்படினா then the signal is not a periodic signal. Clear? That's all, right? Anyway, getting back. Now when we have more than one signal, anyway, and remember one more thing, for a periodic signal we can directly apply the time period. இன்னொரு ஃபார்முலா என்ன சொன்னேன்? If a signal is periodic, then the formula is t is equal to 2 pi by omega. Time period அப்படினா directly you can find. இப்போ நான் லாஸ்ட் கேஸ் என்ன சொல்லிருந்தேன்? x of t is equal to sin t அப்படி நம்ம டிஃபைன் பண்ணனும். What is the value of omega here? Sin of omega t. Omega is 1. So when omega is 1 substitute பண்ணா 2 pi by 1 will become 2 pi only. Directly you can obtain the value of fundamental period. So with the help of this one also we can test the signal, right? Signal the periodic இருந்தா நீங்க இதில செக் பண்ணும்போது you will get the answer. Clear? You can directly obtain the value of fundamental time period of the given signal. Clear? So getting back, so that is all about periodic signal. I hope now you are getting the clear idea, right? Okay. For an example, if I have more than one signal, right? If I have more than one signal, right? So let us see what will happen. More than one signal vandha first find out the time period of the first signal. T1 is equal to same formula. Using the same formula, 2 pi by omega 1. Find out the value of T1. If I have one more signal, T2, idoda corresponding time period, T2 is equal to 2 pi by omega 2. We have to find out the time period of the second signal, and then that is the step number 1. Right? ஒரு ரெண்டு சிக்னல் 2 or more signals வந்து எக்ஸாம்பிள் கொடுத்திருக்காங்க அப்படினா how to check whether the given signal is periodic or not. For that, find out the value of T1 for the first signal, T2 of the second signal, and then take the ratio with T1 by T2. That is the first one divided by second one. Right? So then what will happen? நீங்க T1 க்கு T2 க்கு ratio எடுக்கும்போது if the resultant number will become rational, right? If the number is rational number, if it is a rational number, then the given signal is said to be a periodic signal, right? Then the given signal is said to be a periodic signal. Then for a periodic signal, the resultant time period will become, just we have to consider the Lcm of time period T1 and T2. Just we have to take the LCM of T1 comma T2. Clear? So that is the procedure to obtain the value of fundamental time period when we have more than one signal, right? So let us see various examples to find out the value of time period. Let us see. Actually, this question was asked in our examination. The question is find out the time period of the given signal, right? Whereas we have the linear combination, right? So the linear combination guys, listen. The procedure is step number 1. Find out the value of time period T1 for the first signal. Find out the value of time period for the second signal. Find out the value of time period for the third signal. T1, T2, T3. And then step number 2. Take the ratio between T1 and T2. That is T1 by T2. Again, take the ratio between T1 by T3. Suppose if I have more than one signal, T4, T5, T4, I have one more signal T5, and then I have one more signal. Fundamental is your T1, and then you have to take the ratio between T1 by T4, and then take the ratio between T1 by T5, and so on. You have to find out the value of T5 by Tn up to the nth combination, right? Just we have to take the ratio between T1, fundamental by second one, fundamental by third one, fundamental by fourth one, fundamental by fifth one, fundamental by nth one. Like that, after taking the ratio, if all the ratios are going to be rational, rational number of then the signal is said to be periodic, right? If all these ratios are said to be rational, then that number is said to be, then the signal is said to be periodic signal. Then you can find out in the second step. So the fundamental time period of the signal is simply LCM of T1, T2, T3, etc. Tn. You can consider the all time period and then just take the LCM in order to obtain the resultant fundamental time period. This is the general procedure to find out the fundamental time period of the linear combination of more than one signal. I said if I have only one signal, then simply T is equal to 2 pi by omega will give you the answer. You can simply keep your answer itself, right? But the thing is, when I have more than one signal, the problem is what? We have to go for the standard procedure. Shall we proceed? Yes. Just pause the video and do it by yourself, right? Now I will explain, right? Some of you might be having doubt with the rational number, I know, right? I will explain, don't worry, right? That's why I took this example, it was asked in your examination, right? So let us see. First, find out the value of T1. What is the procedure? T1 is equal to 2 pi by omega 1, right? It should be equal to 2 pi divided by omega 1. Cos omega t. Omega value 2. So 2 getting cancelled, it will become pi. T1. Find out the value of T2. T2 is going to be 2 pi by omega 2, right? T2 is going to be 2 pi by omega 2. So that is going to be 2 pi by omega 2 cos omega t. Omega is 3. So that is going to be 2 pi by 3. Again, let us find out the value of T3. If I find the value of T3, T3 is going to be 2 pi by omega 3. So that is 2 pi by third signal, omega 3 cos 5t. So that is going to be omega 3 cos omega t. Omega is 5, right? So that is 2 pi by 5. Next step, just take the ratio between T1 by T2. First you have to check the fundamental with the second one and then fundamental with the third one. Because only we have two signals now. T1 by T2 should be equal to, what is the value of T1? 5. What of the value of T2? T2 should be equal to 2 pi upon 3. Pi getting cancelled, it is become 3 by 2. Now, is it rational number or not? Yes, it is rational number. Why it is called rational number? Rational number in the sense, if the numerator and the denominator are going to be an integer, then that is called rational number. That's all. If both the denominator and the numerators are going to be an integer, then that is called rational number. Rest of all combinations are said to be irrational. For example, if I have 1 by root 2, see there, numerator I have integer, whereas in the denominator I have square root value. Root 2 value 1.414, that is not integer, so that is irrational number. For example, I have 1 by pi, irrational. I have pi by 2, irrational. Why? Pi is not proper integer value. So, rational number in the sense, your numerator and denominator are going to be considered as an integer number. If both are integer, then the ratio is called rational. Then the ratio is rational, right? So, anyway, T1 by T2 is rational. Let us check. Two conditions may satisfy. I said all the combinations. T1 by T2 is rational. Yes, it is rational. What about T1 by T3? Let us check. T1 is how much? T1 is given as pi, whereas T3 is how much? T3 is given as 2 pi by 5, right? Pi getting cancelled, I am getting 5 by 2. See there, numerator I have 5, denominator I have 2. So 5 is an integer, 2 is an integer, both the numerator and denominator are going to be an integer. So that is also called a rational number. Now rational number resultant what will happen? Both are rational. So in resultant the given signal is said to be a periodic signal. Given signal is said to be a periodic signal. For a periodic signal, how will you find out the fundamental time period? Time period T is going to be just LCM of T1, T2. This is T1, T2, T3. Shall we take? Yes. Let us proceed. LCM of, right? T1 is, what is the of T1? T1 is pi, T2. T2 we are going to consider 2 pi by 3, T3. T3 we are going to consider 2 pi by 5. Now what I am going to do? The next step, simply take pi outside. Take pi commonly outside, because where LCM will be taken only for numbers. 5 you can take it out commonly, right? So pi then we have to consider LCM of, in the bracket I am considering 1, 2 by 3, 2 by 3, 2 by 5, 2 by 5. Now we have to find out the LCM for these fractional numbers. How will you find out the LCM? See there, let me conclude a few more things, because in the aptitude we need some aptitude knowledge to find out the answer for this question. Anyway, let us proceed further. Now see there, LCM of fractional numbers 1 by 2, 2 by 3, ratio on the how will you find out the LCM, right? So let me write. For an example, question is LCM of, right? The question is LCM of 1 by 2, right? Let me consider P by Q, R by S, let me consider T by Y. If it is given like this, now how will you find out the LCM? LCM of this number should be equal to, LCM of the above combination should be equal to LCM of the numerator denominator divided by HCF of the denominator. That is how we are finding the LCM. Fractional numbers in the fractional numbers numerators the LCM find denominator we have to find out the HCF. That is the general procedure. In this case, it can be written as LCM of numerator values are what? P, R, T, whereas in the denominator HCF, highest common factor, denominator people are going to be Q, S, Y. So that is how we are finding the LCM for rational number. Right? In fractional number, we have to take like this. Normally we know. I hope you are knowing this process. If you are not knowing, please go on to refer some YouTube channels or something. You will get the answer. Let us proceed with this. Now the given question, what we have? We have 1, 2 by 3, 2 by 5, right? So let us find out the answer for this question. Wait a minute, guys. I'm really sorry. Yeah. Let us find the answer for this question, right? It is bleeding actually. I'm really sorry. Yeah. Let us find the answer for this one. Let us see for our question how to find out the answer. So the time period T is equal to, in the same way, it can be written as LCM of numerator. Numerator in 1, 2, 2, denominator HCF. We have to consider the common factor, highest common factor. Here we have 1 by 1, 3, we have 5. Let us proceed with this. What is the LCM of 1, 2, 2 will be equal to what? Actually we have pi here. Guys, here 5 is common here. LCM of 1, 2, 2 is what? Just 2 only, right? There is in the denominator HCF of 1, 3, 5. HCF in the sense highest common factor. That is going to be 1 only. See there, this is common 1. Here also we have 3 into 1. Here also 5 into 1. So the common factor is 1. So such that it is going to be 2 pi. Fundamental time period is going to be 2 pi. And one small request to you all. I hope some of you might not knowing these things. That is how do you find out the value of LCM, that is least common factor, and HCF highest common factor, because we people are not giving priority for the aptitude questions, right? But it is very fundamental basics. You can see this type of questions on YouTube. There are many people are taking aptitude questions. If you are not getting the idea about these things on YouTube, just you can refer our 9th standard books or 10th standard books. There you can find out these things. I think 9th standard, right? So there you saw that is you can get the clear idea about the LCM and HCF functions. That is how to get the LCM and HCF of our functions. Clear? So after that, please go through it once. I am repeating once again because this part is very important. Because here I cannot explain all those things, right? That is waste of time for mine because we are in signals and system. We are not in aptitude, right? So just find out the procedure to find out the value of LCM. Just spend 50 to 20 minutes. Don't leave your time. That is you have to spend. I am repeating once again. You have to spend because that basic is very important, right? So the LCM of 1, 2, 2 is going to be 2. HCF is going to be 1 only. So in result, the fundamental time period is going to be 2 pi. right? So the conclusion is, for the given signal, my fundamental time period is going to be what? 2 pi. Are you getting me? Very simple. Step number 1, find out the value of t1, t2, t3. Step number 2, t1 by t2, t1 by t3. If they are rational, then there is periodic. For a periodic signal, we will have a fundamental time period. Suppose, then you know how to find out the fundamental time period at all. Suppose in this case, let me do one thing. I will take, instead of taking 5t, let me take 4 pi into t. Let us see how to find out the fundamental time period for the same signal, right? If you want to find out the fundamental time period for this signal, what shall we do? Again, take these signals, find out the value of t1. How will you find out the value of t1? The procedure to find out the value of t1 is 2 pi by omega 1. So that is going to be 2 pi by omega 1 is 2. So I am getting pi. Whereas time period t, right, sir, 2 I am going to get. 2 is what? 2 pi by omega 2. So that is going to be 2 pi by value of the omega 2 is 3. So that is going to be 2 pi by 3. And then we are going to consider t3. So t3 is going to be 2 pi by omega 3. So that is going to be 2 pi by omega 3 is how much? 4 pi. So I am getting 1 by 2. Shall we take the ratio now? Yes. Take the ratio between t1 by t2. We know how to do the procedure. t1 by t2 is giving me pi divided by 2 pi by 3. Pi getting cancelled. Yes, I am getting rational number, that is correct. Second case for him, let me check. t1 by t3. When I am taking the ratio between t1 by t3, t1 is pi. Yes, t3 is 1 by 2. So I am getting 2 pi. Is it rational number? No. Rational number in the sense, in both numerator and denominator, I have to consider the integer value. Pi is an integer. Is it integer? No. Pi is not an integer number. So the conclusion is, out of these two ratios, one of the ratio is not going to be non-rational, that is irrational. We can write irrational or non-rational number. If it is not a rational number, then the given signal is said to be an aperiodic signal. For an aperiodic signal, there is no fundamental time period, right? So the answer is option. The 4 options கொடுத்திருப்பாங்க. Question will be, you will be tested. That is, என்ன கேட்டிருப்பாங்க, find out the fundamental time period for the given signal அப்படினா question கேட்டிருப்பாங்க. But அதுல 4 options இருக்கும். In 3 options you can find out the values like t is equal to 2 pi, 3 pi, 4 pi அந்த மாதிரி time period கொடுத்துட்டு, in the final option you may have none of the above or you may have aperiodic. Definitely out of these two you can expect one thing, right? So that's why you can predict the answer for the question. Clear? So let us see the next one. Let us see the next one. Actually, in this question, again, you are asked to find out the fundamental time period, right? First, to test whether the given signal is periodic or not. What is the condition? To obtain the periodicity, just to take x of t and test whether it will become equal to x of t plus t or t minus t. In the condition satisfy பண்ண முடியுமான்றதை check பண்ணி பாருங்க. Actually, you have to go with the trial and error only. But see that after practicing some 4 or 5 questions itself, you will come to know, okay, how to check the whether the given signal is periodic or not, right? So the thing is, let me break it for a better understanding. I will take this signal into 2 half. First, anyway, for this given signal, we are requested to find out the fundamental time period. Before finding the fundamental time period, we have to know whether the given signal is periodic or not. That is very important, na? Yes. So instead of going with that one, first I will conclude. Take the sin pi t first. Common observation. Suppose sin pi t, sin times of 10 pi t மட்டும் தனியா வந்ததுன்னு வெச்சுக்கோங்க. இதுக்கு மட்டும் fundamental time period கேட்டேன்னா, by default we know sin pi t 10 pi t is what? Is a periodic signal. நான் இப்ப சொல்லிருந்தேன் இல்லையா? For example, x of t is given as, let me take, x of t is equal to sin of 10 pi t. Right? X of t is given as sin of 10 pi t. Now, I am just checking this condition. For that, I am trying to find out the value of x of t plus t. Up and over, that is going to be sin of t. Right? What we have to consider? Actually, we have to consider 10 pi. T will be replaced by t plus t. T will be replaced by t plus t. Right? In order to apply, in this case, I have to test. If you open, if you want to open up the bracket, if I am opening the bracket, it will become sin 10 pi t plus it is going to be 10 pi fundamental time period t. Just see that t will be simply replaced by t plus t. I think I took one more example in our last case. I mean in the last video. I don't know whether it had been replaced by t plus t or directly. I did not remember. 10 pi t plus t. I was just recollecting. Faster just check guys, listen. T will be replaced by t plus t. Okay, right now remember, from this moment onwards, just remember this one because I thought I took directly. Right? Please correct it by yourself, no problem. Right? Okay, because see, simply see that t will be replaced by t plus t. Where we have t, this is t. t alone will be replaced by t plus t. Clear? If I open up the bracket, that is the resultant case. Anyway, the conclusion is what I have to do. This sine of 10 pi t plus 10 pi caps t should become equal to what? Once again, இது எதுக்கு ஈக்குவலா வரணும் அப்படினா sin of 10 times of t க்கு ஈக்குவலா வரணும். That is the condition, right? இப்போ x of t யும் இந்த condition x of t plus t ஈக்குவலா கொண்டு வர முடியுமா? இந்த condition நம்மளால கொண்டு வர முடியுமான்றதை நீங்க செக் பண்ணி பார்க்கணும், right? In order to satisfy this condition, I have to choose the proper value for your 2t. Sorry, t க்கு வந்து நீங்க proper value choose பண்ணி பார்க்கணும், right? அப்ப நீங்க t க்கு வந்து ப்ராப்பரா என்ன வேல்யூ choose பண்ணலாம்? Least value. Just go from the least possible value. Least possible value, right? If you are going from the least possible value, for example, what we can consider, right? For example, அது நீங்க என்ன பண்ணீங்கன்னா starting சார் எனக்கு இது வந்து கரெக்ட்டான வேல்யூ தெரியல. டவுட் வந்தா just take this function, just find out the fundamental time period. T is equal to 2 pi by omega. 2 pi divided by omega is given as what? 10 pi. Just to divide this one, pi by getting cancelled, it is going to be 1 by 5. Just நீங்க இது ஃபைண்ட் பண்ணிட்டு நீங்க சப்ஸ்டிட்யூட் பண்ணுங்க directly. இப்போ இத சப்ஸ்டிட்யூட் பண்ணி பாத்தீங்க அப்படினா what will you get? 10 pi into it is going to be 1 by 5. So it is become 5 by getting cancelled. I am getting 2 pi. See that I got the function. So that is sin of 10 pi t plus 2 pi. So what I can do? Sin of 10 pi t. Sin of t plus 2 pi should be equal to sin t only. Sin of anything sin theta plus 2 pi should be equal to sin theta only. So that is sin 10 pi t. What is the conclusion? Again I am getting in the condition satisfy ஆகுது at t is equal to 1 by 5. So that is how we are finding. Yes, at t equal to 1 by 5 the given signal is said to be periodic. Clear? அப்ப நீங்க என்ன பண்றீங்கன்னா first even நீங்க trial and error procedure ஒவ்வொண்ணா போட்டு போறது வேற just follow this value. என்ன பண்றீங்க அப்படினா first replace t by t plus t. Replace பண்ணிட்டு just find out the value of அப்ப given function எடுத்து ஃபங்க்ஷனுக்கு டைம் பீரியட் ஃபைண்ட் பண்ணி அதை எடுத்து வந்து நீங்க சப்ஸ்டிட்யூட் பண்ணி செக் பண்ணி பாருங்க இந்த கண்டிஷன் satisfy ஆனா yes that is periodic otherwise that is aperiodic. Anyway sinus and signal is periodic only na we know we can directly define. For your understanding I was repeating this once again, right? So anyway x of t கொடுத்திருக்காங்க find out the value of x of t plus t. X of t plus t ஃபைண்ட் பண்ணி முடிச்சதுக்கு அப்புறம் லாஸ்ட் ஸ்டெப்ல வந்து t ஓட வேல்யூ take the original signal, find out the value of time period, substitute it, check whether this condition is satisfied or not. If it is satisfied, yes, it is said to be periodic. And with the fundamental time period of t is equal to 1 by 5. Let us take our question, right? So இந்த மாதிரி தனியா வந்து problem கிடையாது. பட் இப்போ பாருங்க, our signal had been multiplied by an exponential function. That is exponentially decaying signal. Right? See that e power minus 70 அப்படிங்கிறது exponentially decaying signal. Anyway, நான் டைரக்டா சொல்லலாம் aperiodic signal இது periodic கிடையாது அப்படிங்க. Why? Because this aperiodic signal is going like this. If I draw the waveform for this aperiodic signal, e power minus 70, it is keep on going like this. Just you can draw the waveform. E power minus 70 க்கு t க்கு பதிலா நீங்க சப்ஸ்டிட்யூட் பண்ணுங்க. at t equal to infinity நீங்க r நீங்க சப்ஸ்டிட்யூட் பண்ணுங்க. t க்கு minus infinity போடிங்க அப்படினா e power minus 7 into t க்கு பதிலா minus infinity போடினா e power infinity should be equal to infinity. So at t equal to minus infinity, magnitude is minus infinity. Magnitude of the signal is infinity. At t equal to 0, e power 0 will become 1. At t equal to plus infinity, it will become 0. Why? T equal to plus infinity போடினா minus into plus infinity become e power minus infinity. E power minus infinity will be 0. So that signal is keep on exponentially decaying signal. இது கூட நீங்க ஒரு sinusoidal signal மல்டிப்ளை பண்ணீங்க அப்படினா அந்த sinusoidal signal எப்படி வரும்? It is keep on going like this. It is keep on going. Finally it will become 0. Is it periodic signal? Periodic signal அப்படினா எப்படி இருக்கும்? It has to repeat. அதோட ப்ராப்பர்ட்டி வந்து திரும்ப திரும்ப லீனியரா ரிப்பீட் ஆகும். இந்த மாதிரி இதுக்கு அப்புறம் இதே மாதிரி ஸ்ட்ரக்சர் வரும். இதுக்கு அப்புறம் இதே மாதிரி ஸ்ட்ரக்சர் வரும். இங்க அந்த மாதிரி தான் வந்திருக்கா? No. So directly I can say that the given signal is aperiodic. Given signal is aperiodic. Anyway, let us test. How will you test this signal? We have to apply this condition. அதனா சொன்னலையா by practice அப்படியே நீங்க ஒரு சிக்னல் மட்டும் இந்த மாதிரி கொடுத்தனால டைரக்ட்டா பாக்கும்போது நீங்க கண்டுபிடிச்சிடுவீங்க. But the thing is by practice anyway if you have a doubt let me read procedure வழியா நீங்க போனாலும் you will get the answer. But logical x of t is equal to e power minus 70 into sin 10 pi t. That is what it was given. Now let us evaluate the value of x of t plus t. இப்போ இது எப்படி எழுதுவீங்க? It can be as e power minus 7 wherever we have t will be replaced by t plus t, right? Dot sin of 10 pi t will be replaced by t plus t. Yes or no? Now just check it once. E power if the bracket open பண்ணா e power minus 70 plus what I can say both are going to be minus na. So minus 70 minus 7 times of fundamental time period dot sin of if you open up the bracket it will become 10 pi t plus 10 pi fundamental time period t. Now tell me whether your exponential function is the periodic one. No. Here itself I can control for all value of time period. இப்போ நீங்க t க்கு எந்த வேல்யூ போட்டு பார்த்தாலும் you cannot change the periodicity. அதாவது மீனிங் என்ன சொல்ல வரோம் அப்படினா e power minus 70 திரும்ப என்ன வரும் அப்படினா minus 70 க்கு we have to choose some value. இந்த t க்கு நீங்க ஒரு வேல்யூ சூஸ் பண்ணனும். அப்படி நீங்க சூஸ் பண்ணும்போது ரிசல்ட் என்ன வரும் அப்படினா this value has to e power minus 70 minus 70. This total value will become once again equal to e power minus 70. We have to choose minimum value 1 2 3 4 samples. 0 ல இருந்து போகக்கூடாது. You have to start minimum sample 1 2 3 4 5 6. நான் செக் பண்ணி பார்க்கறேன். நீங்க 1 போடுங்க 2 போடுங்க 3 போடுங்க எந்த வேல்யூ போட்டாலும் this function is never become equal to this function. So out of this, right, multiplication for ரெண்டு சிக்னல் இருக்கு. One is aperiodic, another one is periodic. ரெண்டு பேரையும் மல்டிப்ளை பண்ணி உடனே result will become aperiodic signal only. Just on waveform கூட வரைஞ்சிக்கோங்க, right? So the first signal is aperiodic, second signal might be periodic. Yes, it is periodic, I know. Just now we saw in the signal மட்டும் தனியா பார்த்தா periodic, but the periodic signal acting multiplied with the aperiodic, because of that in result this net signal is going to be aperiodic. For aperiodic signal time period is not defined. That's all. Time period is not signal, that is not defined. So that is how we are finding the time period for our signals in our time domain, that is continuous time domain, right? Okay, that is the procedure to obtain value of time period for all the signals in continuous time domain. Suppose if the same thing will be you have to test it in discrete time domain, then what will you do? Very simple. In discrete time domain, I said the relation is in continuous time domain we are considering t, in discrete time domain we are going to consider n. I said that n will be initially we are considering n times of t only, fundamental capital T. T will be replaced by nt, and in result that signal is going to be drawn in the axis x of n versus n only with the sampling interval of t. Clear? With the sampling interval of t. So that is how we are getting the discrete domain signal. So for example, if a signal is given in discrete domain x of n on the discrete domain la kudukranga appadina, the signal is, let me take x of n equal to for example cos omega n indha mari kuduthanga vechukonga. Guys listen, that is very important. The thing is, what is the difference in continuous time domain, right? In continuous time domain I will take the same example cos omega t. Let us see the difference between continuous time domain and discrete time domain. In continuous time domain, first the thing is to find out the periodic signal, the formula is t is equal to 2 pi by omega, and the value of t must be a real number. The value of the t must be a real number. T வந்து எப்பவுமே எப்படி இருக்கணும் அப்படினா it has to be a real number in case of continuous time domain. Now when I am looking for discrete domain your fundamental time period will be defined by caps n, capital N, and I am going to use the same formula only. 2 pi by omega is the general formula, but it will be multiplied by an integer m, right? It will be multiplied by an integer m, right? Same formula, but why I am multiplying by m? I will let you know. But thing is, right now remember the conclusion is in case of discrete domain the value of time period is always be an integer. In discrete domain the value of the n will always be an integer, whereas in the continuous time domain it does not matter whether your time period is integer or you have some value like root 2 pi, any value can be considered in time domain, because but the thing is it has to be a real number. You cannot consider imaginary things at all. It has to be a real number, whereas in the discrete domain it has to be an integer. Your value of the time period has to be a proper integer. It might be 1 2 3 4 5 6 7 8 like that. A proper integer only will going to be considered as a fundamental time period of your discrete domain. First difference, very important. Clear? So after knowing these things, let us proceed. And the condition is in case of continuous time domain, to satisfy the periodicity, x of t should be equal to x of t plus or minus t. Either you can consider plus t or minus t, it's up to you, right? Whereas in the discrete domain the same procedure is, here we are going to consider x of n should be equal to x of n plus or minus, we are going to consider capital N. We are going to consider capital N. So because here that n is your fundamental time period, here capital T is our fundamental time period, and here the procedure at all remains same. Again we have to take t1 by t2, t1 by t3, t1 by t4, right? While taking the ratio, all these numbers will become rational number, and here also we have to repeat the same procedure, n1 by n2, n1 by n3, n1 by n5, like after taking, right? ingame enna varudina t1 by t2, t1 by t3, t1 by t4, t1 by t5, that is the procedure. Here n1 by n2, n1 by n3, n1 by n4, n1 by n5, n1 by nn last, and then LCM of t1, t2, etc. tn. Here LCM of n1, n2, nn, etc. Clear? So that is the difference between continuous time domain and discrete time domain. But the thing is, here what I will told you, n must be an integer. That is very important, right? So let us proceed how to find out the value of n. Let us check, right? In case of discrete domain, you have to, for an example, let me take the same signal, right? That is the given signal, and you are requested to find out the time period of the given signal. If the signal வந்து நீங்க time period calculate பண்ணனும் அப்படினா, let me take some value for this. Given it is cos 2n, and you are requested to find out the fundamental time period. n ன்னு பாத்தீங்கன்னா that is discrete domain, right? So the corresponding time period condition என்ன? X of n is given. Now various x of n plus n. Let us check. X of n plus n x of n equal ஆகும், கரெக்ட்டா? So x of n plus n should be equal to cos of 2 times of n will be replaced by n plus capital N. If I open up the bracket, it can be further written as cos of 2n plus twice of capital N. Same procedure. Procedure all not going to be different. But the thing is, what I have to consider, எனக்கு என்ன வரணும் அப்படினா, if your signal is said to be periodic signal இருந்தா x of n உம் x of n plus n உம் ஈக்குவலா வரணும். அந்த கண்டிஷனை நம்மளால கொண்டு வர முடியுமா அப்படிங்கறத நீங்க செக் பண்ணி பார்க்கணும். If you want to testify this condition, you have to find out the value of n, right? நான் சொன்னேன்லையா, இந்த இடத்துல n க்கு வந்து உங்களால டைரக்ட்டா போட முடியல, just to find out the value of n from here. The formula is n is equal to 2 pi by, what is the value of omega? Omega is given now, omega already given, that is 2. Omega is already given 2, right? With m is going to be an integer. M is going to be an integer. Let me cancel it. 2. Next, what I am having here, m into pi. But do remember what I had been told you. N cannot be, you cannot consider this m phi, you cannot consider this pi at all. N can be, that is n cannot be what I can say phi or root 2 and my value, so you cannot consider it for n. N is must be an integer. N is must be an integer. Let us sample. அப்ப நீங்க என்ன பண்ணணும் அப்படினா, phi I cannot consider, but I have to consider proper value of m. We have to choose the proper value of m in order to obtain the minimum sampling interval. n க்கு வந்து நீங்க ப்ராப்பரான ஒரு இன்டர்வல் வந்து चूஸ் பண்ணனும், right? Let us see. அப்ப நான் என்ன பண்ணறேன்னா, see, let me proceed further. Now I have to choose a proper value for n in order to obtain, right? அப்ப நீங்க என்ன பண்ணணும், cos of 2n has to be equal to cos of 2n plus 2n should be equal to what? Cos 2n, right? அப்ப ஈக்குவல் வரணும் அப்படினா what will you do? Let me write these things. Now this 2n should be equal to, right? அப்ப என்ன வரணும் அப்படினா, this 2n should be equal, it has to satisfy the value of 2 pi. It has to become equal to the value of 2 pi. அப்ப இது வந்து 2 pi க்கு ஈக்குவலா வரணும். Okay, that is correct only. But the thing is, what I cannot do, n க்கு வந்து என்னால என்ன பண்ண முடியாதுன்னா இன்டிஜர் வேல்யூவை चूஸ் பண்ணவே முடியாதுங்க. Why? இந்த cos of 2 pi ஓட வேல்யூ திரும்ப என்ன வரணும்? Cos of 2n plus 2n திரும்ப வந்து cos 2n க்கு ஈக்குவலா வரணும் அப்படினா கண்டிப்பா நீங்க என்ன பண்ணணும்? At least n க்கு வந்து you have to consider pi. Pi ஐ சப்ஸ்டிட்யூட் பண்ணாதான் நமக்கு தெரியும் இல்லையா, cos of theta equal to cos of theta plus 2 pi. That is the condition. அப்ப அந்த கண்டிஷன் நம்ம கொண்டு வரணும் அப்படினா, here n க்கு நான் pi ஐ चूஸ் பண்ணா மட்டும் தான் I am getting this answer, but I cannot choose pi for n. So what is the conclusion here? Given signal is said to be a aperiodic signal. Given signal said to be a aperiodic signal. Why it is aperiodic signal? Why? Because I am unable to choose the proper integer value for n. Such that நீங்க choose பண்ண integer value என்ன வரணும்? Cos of 2n plus 2n should become equal to cos 2n. அந்த மாதிரி கண்டிஷன் வந்து எனக்கு இங்க தான் ஃபெயில் ஆயிடுச்சு. When I was trying to calculate the value of n, I had been failed to obtain the 2 pi by omega into m தான் நம்ம சப்ஸ்டிட்யூட் பண்ணோம். So what we got, 2 pi by omega is said to be 2 and here is going to be m. See the 2 is getting cancelled. n ஓட வேல்யூ ப்ராப்பர் இன்டிஜரா வரணும்னு நான் சொன்னேன். See that here itself I am getting pi into m. இப்போ m ஓட வேல்யூ m அப்படிங்கிறது ஒரு இன்டிஜர்ங்க. இது நம்ம என்ன चूஸ் பண்ணோம்னா 1 2 3 4 5 6 அப்படி நீங்க चूஸ் பண்றது மூலமா n ஓட வேல்யூ வந்து நமக்கு இன்டிஜரா வரும். சரி, என்ன நீங்க குழப்பறீங்க? ஃபார் எக்ஸாம்பிள் இப்போ நீங்க என்ன வந்துன்னா n is equal to, for example நீங்க வந்து 1/3 அப்படி வந்து வெச்சுக்கோங்க, ரைட்? எனக்கு pi வரல 1/3 வந்திருக்கு. இப்போ நாம என்ன வரணும், n ஓட வேல்யூ இன்டிஜர்ல வரணும். அப்ப நீங்க m க்கு என்ன பண்ணுவீங்க? m is said to be 3. Such that what will happen? 3 is getting cancelled, I am getting integer value. So minimum possibility, m க்கு வந்து least possibility நீங்க चूஸ் பண்ணனும். 1 2 3 4 5 6 அந்த மாதிரி least value நீங்க चूஸ் பண்ணும்போது இந்த fraction cancel ஆயிட்டு n ஓட வேல்யூ ப்ராப்பரான இன்டிஜரா மாறும். இந்த ப்ராப்பரான இன்டிஜர் வேல்யூ ஃபைண்ட் பண்றதுக்காக தான் we are choosing this m here. பட் இங்க பாருங்க, நீங்க m க்கு என்ன வேல்யூ வேணாலும் चूஸ் பண்ணுங்க. m க்கு நீங்க 1 போடுங்க 2, பட் m is said to be an, இதுவும் ஒரு இன்டிஜர் தான். இது நீங்க கண்டிப்பா இன்டிஜர் வேல்யூ மட்டும் தான் கன்சிடர் பண்ணணும். you cannot consider 1/5 அப்படினா நீங்க எதுவும் கன்சிடர் பண்ண கூடாது. அப்ப நான் 1 2 3 4 5 6 மட்டும் தான் இதுக்கு சப்ஸ்டிட்யூட் பண்ண முடியும் அப்படினா I cannot remove this pi. So n is not an integer for this given function, so that is said to be aperiodic signal. Given signal is said to be aperiodic signal. Suppose let us take the same question is given like this. In the alternative way, the same signal, let me consider x of n is given as cos of 3 pi n. Shall we proceed now? Yes. Let us find out the value of n. n is going to be 2 pi by omega into m, integer value, right? Let us see, omega value of 3 pi, so 2 pi by 3 pi, pi getting cancel into m. Now what I had been told you, we have to choose the least possible value of m in order to obtain the integer value of n. அப்ப n க்கு வந்து ஒரு integer value இங்க வரணும் அப்படினா fraction denominator இருக்க வேல்யூ நீங்க கேன்சல் பண்ணனும் அவ்வளவுதான். denominator இருக்க வேல்யூ கேன்சல் ஆகுனா m is said to be 3. கரெக்ட்டா? in order to cancel this 3. அப்ப 3 cancel ஆச்சு, result I am going to get 2. So the conclusion is, இப்போ இந்த m நீங்க கன்சிடர் பண்ணவே தேவையில்லைங்க. நீங்க சால்வ் பண்ணி முடிச்சதுக்கு அப்புறம் நாம என்ன பண்ணலாம், நியூமரேட்டர்ல இருக்க வேல்யூ தான் உங்களோட டைப் பண்ணி நீங்க அப்டேட் பண்ணிக்கலாம். நியூமரேட்டர் இப்போ 2/3 வருதா, 2 is my sample, right? so இந்த m போட்டு நம்ம கேன்சல் பண்ணணும்னு அவசியமே கிடையாது. why for example இப்போ எனக்கு என்ன வந்திருக்குன்னா 9/10 வந்திருக்கு into m வரும். இப்போ இந்த டோட்டல் வேல்யூ 9/10 வருதுன்னா m ஓட வேல்யூ கண்டிப்பா 10 தான். அப்ப டினாமினேட்டர் நம்ம எப்பவுமே கன்சிடர் பண்றது நியூமரேட்டர் is going to be our proper time interval. Directly I can define. In this case we can define, we can bring the integer value for 2, but last case what I had done, எனக்கு என்ன வந்ததுன்னா m into pi வந்திருந்தது. pi நான் எப்படி ரிமூவ் பண்ண முடியும்? m ன்றது ஒரு integer 1 2 3 4 5 6 I can substitute, but I cannot replace by m ஓட வேல்யூ வந்து 1/pi நீங்க சப்ஸ்டிட்யூட் பண்ண முடியாது. so pi cannot be cancelled, so given signal is aperiodic. But now this signal is periodic with n equal to 2. This signal is periodic with n equal to 2. You can test it. Now you can test it. Shall we check? Yes. Now the given signal is what it was given, cos of 3 pi by n. Check பண்ணி பார்த்தோமா? Condition is what? In order to satisfy the condition, we have to go with the xn should be equal to x of n plus capital N. Yes or no? Yes. So the value of xn is what? It is I know, right? X of n plus n find பண்ணுங்க. X of n plus n என்னோட cos of 3 pi in bracket we are going to consider n plus n, that is I am trying to find the value of x of n plus n. I know the value of x of n. So we open பண்ணீங்க அப்படினா we are going to get cos 3 pi n plus 3 pi capital N. Yes or no? Yes. இப்போ நம்ம டைம் நான் என்ன சொல்லிருந்தேன், செக் பண்ணுங்க. இப்போ x of n x of n plus 1 ஈக்குவலா வரணும் அப்படினா நான் என்ன சொல்லிருந்தேன், see x of n ஓட வேல்யூ வந்து cos of 3 pi by n, x of n plus n ஓட வேல்யூ எவ்வளவு, cos of 3 pi n plus 3 pi n வந்திருக்குல. அப்ப நீங்க என்ன பண்ணனும், இந்த whole value should be equal to 2 pi க்கு வந்தா 2 pi க்கு ஈக்குவலா வந்துச்சு அப்படினா definitely I can proceed. Proceed further. நான் என்ன proceed பண்ணிக்கலாம் அப்படினா I can easily, what I can say, this whole term equal to 2 pi in the sense cos of theta plus 2 pi should be equal to cos theta. இந்த condition satisfied, given signal set to be a periodic signal. அப்ப என்ன பண்ணலாம், in order to bring that condition, let me check. Find out the value of n. n is going to be 2 pi by omega into small integer m. So 2 pi divided by omega is how much, 3 pi into the value of m I don't know, but let me cancel it. அப்ப m ஓட வேல்யூ என்னது, minimum value 3 தான். எனக்கு denominator cancel ஆகும் அவ்வளவுதான். So n is going to be 2 fundamental time period. அத அப்படியே நீங்க சப்ஸ்டிட்யூட் பண்ணீங்க, it is going to be cos of 3 pi n plus n க்கு பதிலா 2 சப்ஸ்டிட்யூட் பண்ணீங்கன்னா 2 into 3 pi will become 6 pi. Cos of theta plus 2 pi, cos of theta plus 4 pi, cos of theta plus 6 pi, cos of theta plus 8 pi should be equal to cos theta only. So that is equal to what? Cos of 3 pi n only. So the condition is satisfied, given signal is said to be a periodic signal with the time period n is equal to 2. That is how we are finding the fundamental time period for our discrete signal. Now you might get the very clear idea. Clear? Don't be confused guys, you have to see, this is very simple questions, silly questions, but you have to trace. For your understanding, let me take one more example here to get the very clear idea about the discrete domain, right? In case in the discrete domain the given signal is x of n should be given as e power j times of 2 by 3 times of pi into n. That is what it was given, and you will be requested to find out whether the given signal is periodic or not. How will you test it? For that, let us consider. We have to find out the value of x of n plus n. n plus n find out, that is going to be e power j times of 2 by 3 pi, n will be replaced by n plus n. If I open up the bracket, it is going to be, can be written as e power j, that is become 2 by 3 times of pi into n plus 2 by 3 times of pi into capital N. Yes or no? Now I have to choose the proper value for n. Actually we are supposed to go with the trial and error procedure only, but I don't want to go with that one. What I told you, find out the value of n properly. Directly இங்க இருந்து n ஓட வேல்யூ சப்ஸ்டிட்யூட் பண்ணி ஃபைண்ட் பண்ணி நீங்க சப்ஸ்டிட்யூட் பண்ணி செக் பண்ணி பாருங்க. அப்படி நீங்க சப்ஸ்டிட்யூட் பண்ணும்போது என்ன ஆகும், this function once again become equal to this function. வந்துருச்சுனா okay, given function is periodic. Let us check. So n is, general formula is what, 2 pi by omega into m. One thing we have to understand, this n is must be an integer, that's all. So let us proceed, that is 2 pi by omega is how much here, j times of omega n. Guys, listen, e power j omega e power j theta நம்ம எழுதுவோம் cos theta plus j into sin theta, correct? So that is omega into n only. This is omega, e power j omega n, right? So omega is equal to what? 2 by 3 into pi, that is L of omega. So 2 getting cancelled, pi is getting cancelled. I am getting what? 3. See there, 3 into m only, but m is going to be 1 now. Why? I don't have any denominator already. If there is nothing in the denominator, then the value of denominator is considered as 1, such that m also going to be 1. m oda work enna appadina denominator cancel pannom. Integer values, denominator or integer value cancel pannom. Avladhaan, right? So that is going to be equal to 3. It is over, right? So the conclusion is n is going to be 3. Right? Let us substitute. Check panni paakalama. Substitute panni paathamna I am getting e power j times of 2 by 3 pi into n plus 2 by 3 pi into n equal to 3 substitute panna 3 getting cancelled. See there, e power j theta plus 2 pi. Once again it will repeat. Or sinusoidal signal or what I can say, that is called a complex signal. E power j theta is nothing but cos theta plus j sin theta. That is also trigonometric function only. So that will give you what? Theta plus 2 pi will give you theta only. In case of cos theta, sin theta, e power j theta, r will give you theta plus 2 pi will give you theta only. So in the conclusion, in resultant I am getting e power j 2 by 3 into pi n only. So the given signal is said to be a periodic signal. The given signal is said to be a periodic signal with the time period n is equal to what we found 3. Clear? Let me take the same example. Let me slightly change the data for to get the clear idea about this periodic values conclusions, right? So let me take one more example with this. Suppose same function is given, x of n is given as e power j. Let me write with just 2 by 3 into n. Shall we proceed now? Yes. Let us find. Now, in order to check whether the given function is periodic or not, let us proceed and just find e power j 2 by 3. N can be replaced by n plus capital N. So let me expand this one. E power j times of it is become 2 by 3 times of n. Here also I am getting 2 by 3 times of capital N. Shall we proceed further? Yes. Now, in order to check, in the rendu pair equal I have to find out the value of n. That is going to be 2 pi by omega into m. Shall we proceed? Yes. 2 pi by omega is how much? Omega is 2 by 3. 2 getting cancelled. Here I have to consider m. So here I am getting 3 pi into m. Now see there in the denominator I have 1. Right? So this m, this 1 might be cancelled by m. Appo நம்ம m க்கு வந்து நம்ம 1 choose பண்ணா this 1 is getting cancelled. But see there n will become 3 times of pi now. Is it a proper time period for the discrete domain? Time period, continuous time domain la indha mari oru value vandadha, yes it is acceptable. In continuous time domain, if I have such type of variable, yes it is acceptable, because in continuous time domain my condition is time is a real number. In continuous time domain, t is simply said to be a real number. It can be anything. It can be pi or 1 by root 2, root 2, 1 by root 3. Any values can be acceptable, but the value can be a real number. That's all. It has to be a real number. Whereas in the discrete domain, I have to consider n is supposed to be an integer. There will be difference. It is not an integer now, so the given signal is said to be a periodic signal. It is said to be a periodic signal. Clear? Now, I hope now you are getting a very clear idea about this periodicity of the signal, right? So in the next lecture, let us see the next type of signal.